So how does the hardware detect that you're plugged in your USB device? That is when the whole action starts, right? So it is done in hardware. It's a very simple hardware logic, but I will just give us example of that. So here is the host. So USB host, and so you have the host and the device. These are the two types of things that you'll have. Forgetting about the hub itself. Okay, so devices can be of at least traditionally there is something called low speed device or a high speed device. So they have different things, or full speed. I wouldn't say high speed. Of course, USB 3.0 is more. I'm not familiar with those. Okay, so you have these two types of devices. So the hardware needs to not only know whether a device has been plugged in, and the next thing it needs to know is what speed it is operating at, so that it can interact with it. It's like your baud rate detection in UART, right? It's as basic as that. So there are USB, apart from its power and ground, it has two important lines. So one is the what you call USB data plus and USB data minus. So the voltages are relative. Okay, and similarly the devices will also have that. So this is plus D plus D minus. In schematics you will see this in the board schematics, etc. So what happens is these are all before they are plugged, they are independent devices. So in the respective hardware, so in the host, for example, it is tied to the ground using a weak pull down. So it's a 15 kilo ohms kind of thing typically. So you may have something similar for this. So this is 15 kilo ohms. In the device, usually it will be tied to the VCC. So difference is how you tie them. In the low speed device, it is tied to the D minus, and in the high speed, it is tied to the D plus. So basically with that mechanism, simple hardware mechanism, the host, once you plug in, because there is a difference between, so the weak pull down is overruled by the VCC. So there will be a current on the D plus or D minus line, and therefore the host hardware can detect that the device has been plugged in and what kind of speed device it is. It's a very simple hardware trick. So this is all there is to hardware detection. Next, what happens, the second step in this flow is the device identification. So what kind of device has been plugged in? There are, again, a USB device, at least in the Linux context, actually can, so the idea of this is, do you need a special driver? Do I need a special driver? Especially more than that, do I need a special application interface? Special, I am just using in a loose sense. What do I mean by that? For example, there are already existing interfaces like TTY and so on. So they are basically Unix subsystems. So you can plug in a USB device, and it can still actually use the, for example, TTYs, SCSI, and network interface. These are all Linux systems or subsystems which already can be leveraged by a USB driver, or it may require a specific driver. It may require a specific driver. So that so basically, what is the difference? This is basically providing an application interface. Okay, so this is a stream interface, for example, and or it can be providing a different file system interface. So you open, so basically a FOX interface for the application to communicate with the device. So that there are two ways of doing it. Now, that is how the driver will decide how it is providing an interface to the application. That is one part. But identifying the hardware device itself has a certain level of operations that needs to be done. So moment the hardware detects, so hardware detection device, that is done. So in the previous step, the next thing is the host will reset the device. Here, when I say device, it's not the host, it's the other side. So it will do a reset. Then it tries to read from the device. Now, in order, there may be multiple devices plugged in the USB sometimes. So it uses what is called a default address. So using a default address, it will try to read from the device. What does it try to read? It tries to read, basically issuing the tell me about yourself. So here is the host and here is the device. So there is a request response packet exchange between them. So the request is get basically device descriptor. So this descriptor is the key. Tell about yourself, and then the response packet will have the descriptor length plus whatever payload. Payload here is the descriptor actual content, descriptor data, I would say. So this is the first thing that gets done after reset. So the host does the reset and issues this command, USB command, and as per the protocol, if the device is compliant, it is going to respond with this descriptor. So what is the information? This is basically what is the step called enumeration. So after the detection, enumeration is the second step. So what happens in the descriptor data? What is the info in the data? It is basically what kind of device it is. It is device class, subclass, maybe manufacturer ID or vendor ID. There could be product ID, and then serial number, and so on. Sometimes vendor ID it may be different from manufacturer ID, but that's a detail. So basically, these are the kind of the important things are this. And the vendor ID and product ID also helps to identify the right driver for that. So the vendor might have provided a driver to be loaded. So that driver has to be identified. So basically, the device class and subclass tells what class of device. For example, you have storage class, or you may have storage class device or mass storage. Okay, you could have audio, anything. USB is so popular. Yeah. So there are so many classes, and within them there may be subclasses, right? And you may have composite devices also. So basically, the device class, subclass, or the key thing to know what kind of device it is. That is part of the enumeration. Okay, so what happens is once it gets the response, the host will now know whether this device can be dealt with. Will check if this device is recognized. What is, there are steps to that, and if it is accepted, it can be accepted. So otherwise, the OS may prompt the user to install a driver and so on. So this is basically the check that is done. And once assuming that is all clear, it will assign an address for that device, So that is the part of the enumeration step. So, and it also needs to allocate the resources, basically ring buffers, like ring buffers, and so on. Intra-client, whatever resources to be allocated for that device. So this is basically the end of the enumeration step. So the flow is you plug in the device, the host detects the device, then you identify the speed, you get the device descriptor, reset the device and get the descriptor, reset again and assign an address. And then next step is you get the configuration details. That is, there is something called configuration descriptor. And then you get interface descriptor. These are specific to USB. I will not get into that. So you can get many types of descriptors, as much information as required. This is now when you can load the driver. So what information you need? A class of device, subclass, vendor ID, product ID. This will help identify which driver to load. So you need a table. Basically, you need a table in the kernel or in the host, which maps the vendor ID, product ID, and of course the class and subclass information to map to the correct driver to be loaded. Okay, so then we will see what the driver will do. So this is basically completion of enumeration, and then the driver is to be loaded. So let's see what the driver flow is. So now we'll talk about driver flow. Enumeration is done, so that is not an issue. The driver will have to register itself with the kernel. So Subhash talked about it in the previous conversation. So what does that mean? Basically, it will, yeah.
Sorry to interrupt. So the enumeration part is also done by some driver, right? So that would be host controller driver.
Yeah, actually in USB there are two types of drivers conceptually. One is called the bus function driver, okay, which is a low level driver, and then class of device driver. So what basically enumeration is done by this, right? It is independent of what class of device and all the basic enumeration related tasks. And this is the actual driver.
Yeah.
Which is specific to how to deal with a mass storage, how to deal with audio and so on. So it's completely different. So it segregates the low level details of enumeration. And so basically you need to drive the enumeration interchanges. So that is done by bus function driver.
So far what we talked is done by bus function driver, and now driver flow is for the functional.
Yeah, so I'll say class of device driver. Okay.
So for the enumeration part, there's example in a scenario where it's the device is already plugged in and the system is, the first time is booting up and so on. So the enumeration is done at the BIOS level, or the first stage or second stage bootloader, or it is done by the kernel?
Yeah, it is done by the driver, but the bus function driver. And so let's say we said the hardware detects a device, right? So it will generate an interrupt. It will obviously flow into the kernel, or that, the kernel, so USB system may have a bus function driver, which is independent of the class of device driver. So that driver will send the command for, it will do the reset, it will do the command for getting the descriptors and parsing the descriptor response, and then identifying the ID table, vendor ID, product ID table, and then identifying the driver. The loading the driver will be done by the kernel, of course.
Okay, so it means after the second stage boot has loaded, this is where after that only the enumeration is going to take place.
Right? Much later, yeah. Actually, you already entered the kernel here. Of course, the bootloader itself may have to use USB for booting the image, then it may have its own driver for that.
Okay.
So
like,
what I am talking about is when kernel has started.
okay. And it could be different to for other devices like PCI devices. For PCI
Right.
devices, I understand that the enumeration happens at the BIOS first level. Correct. Okay.
Yeah, it will be different. I'm not familiar with PCI, but with USB, this is what happens. And if it is different, it may be specific to the protocol that it defines. But the general idea is that all plug and play hot plug devices require certain enumeration and then certain exchange of information to identify the device. And I would say I'm familiar with USB, so I'm using that example.
Okay.
So enumeration happens first, and then comes registration.
Okay. One last question. If I'm not sure, did I understand correctly? The bus function driver is basically is the driver for the system bus, assuming, or the USB bus, which is going to identify whatever devices are connected to it, right? So I believe that system bus, the bus function driver would have been the system bus is basically the hardware, detection or initialization should have already happened at the BIOS or bootloader level, correct?
Yeah.
Okay.
Yes. Correct.
Okay. Thank you. That's all right.
Okay.
Sorry. I mean, it's important, right? So are we saying like, so the host, so the bus driver initialization happens in BIOS? Because I thought host controller is quite independent, at least in the USB case, and it's a separate driver in the kernel, which gets initialized on the kernel boot, and it does the enumeration.
So both are correct, Subhash. So if at the initial bootloader level, you still need a driver to deal with accessing the image and all that, right?
Right. Yeah.
So to that extent, if the bootloader is BIOS, then it will have. If it is U-boot, it will have such a driver as well. But the kernel, and you don't know what OS you are going to boot next. So obviously, when you boot, let's say Windows, as opposed to Linux, they may have their own bus function drivers and so on. So they have to, once the kernel gets control, it can overrule the BIOS level drivers. But the idea of BIOS is to provide hardware independence. So, but for USB, yeah, you're right. The bus function driver of the OS takes precedence once the OS gets control.
Right, and the enumeration, because it's plug and play kind of devices, which can come into picture even after the Linux has booted.
Yes.
So it has to happen. I mean, obviously there might be some devices hardwired on the board, and those can be enumerated by bootloader or BIOS, but most of the plug and play it has to. Okay.
Yeah. Okay. So basically, the registration part. So one of your questions is about the probe function and all that, right? So basically, what is registration? You are going to register a bunch of callbacks. Okay, what callback functions which are provided by the driver, and so that the kernel can invoke them as part of that driver. So basically, the first and important one is the probe, and other ones are like disconnection. And you may have suspend and resume kind of, at least in USB you have. And I'm not sure about the details, but there is a pre-reset and post-reset kind of function handlers. Okay, so these callbacks have to be provided by the driver, and they are registered with the kernel. And they are the basic interface the kernel has to the driver in order to operate that USB, right? Of course, we talked about what it basically the kernel does with this is basically map them to so there are two parts. The kernel sits in the middle. So this is basically the hardware centric part, and this is basically the application over centric part. So here the FOPs come into picture. So this is the interface. So you have F open, F close, and so on. Here you have these callback functions, which are basically the probe, then disconnection, suspend, whatnot, and of course the basic data related operation. So you may have F read, write, and so on, right? So the kernel sits in between this, and it tries to map these. So when the user says F open, then it may actually do some things, invoke any of the callbacks, or if the hardware interrupt comes, then it may use some of the these functions. So these are the callback functions, and these are the APIs or application. Okay, so this mapping is done based on the particular vendor ID plus product ID. So the ID table basically. So this is basically the one which maps the low level hardware operations done by the driver to the application. Okay, so actually it's not the ID table, it's called the module device table, I think. So it will have a device pattern and all. So when the registration happens, few other things happen. So registering callback is one part. Then there are other things that needs to be done. Basically allocating resources, allocating ring buffers, and things like that for the driver. So that also has to be done. So similar, so after the probe, these things happen. Similarly, when you disconnect, okay, when you do a disconnect, then cleaning up of all allocated resources happen. So these are in the flow, these are the additional things before the driver can be. And allocating ring buffers requires, of course, knowing the endpoints. So whether you have bulk endpoints, isochronous, and isochronous basically for audio kind of endpoints, and then of course the interrupt endpoint. These are the endpoints defined by the USB. For each endpoint, it may have to allocate different ring buffers and set up the system for pushing or pulling data from these endpoints. So these are the things that happen. So to summarize, we start with hardware detection, then the reset and enumeration, and then address allocation for the device. And then once you have all the descriptors, interface descriptors, everything, you will register, the driver will register itself. The right driver is identified, and the driver will register the callbacks for various operations, and then the resources are allocated. Then onwards, the application can operate through these application FOPs kind of interfaces. If it is, if it is using the Linux USB subsystem. Of course, if it is using the TTY or SCSI or something, it may use a different API. So that's basically the flow. So Kamini, are you clear about this?
Yes, Raghu. Thank you so much for explaining. You included a lot of information. One question that I have is, I have, I'm not very sure about USB, but I know PCIe have a call like a PCIe or register, driver register, and also a probe function. So I'm always, confused with what are the difference between these two, and what is the sequence of them being called actually.
Okay, I'm not familiar with PCI, so I won't be able to comment on that. In USB, the enumeration happens first, and then the probe happens.
So it means when you say register the, after the enumerations, then you have the driver, you register the registration in place, right? It means basically registering the callback and so on. Then,
Yeah.
okay.